Thank you for a kind introduction. My name is Takamasa Hasama. I'm a research engineer in Kajima Technical Research Institute. We are based in Singapore, and furthermore, I'm a research engineer in Singapore. This means also very crucial because the Southeast Asia, including Singapore, is very, very crucial to reduce the carbon footprint in terms of the big impact for all the global climate. So today I'd like to talk about our activities in terms of the private company. Furthermore, I would like to introduce our new building, considering with the reducing of the energy. Yeah, this one. This is a content. Firstly, please allow me to introduce our company a little bit. The second, I'd like to explain our activity in terms of the private company. The third, I'd like to introduce our new building in Singapore. Yeah, firstly, I'd like to explain our company. Our company, Kajima Corporation, is a construction company in Japan. So currently, the employee is approximately 8,000. So our activity is not only in Japan, but also all over the world. Especially, we are focusing on the Southeast Asia, including Singapore. So one of the feature of the Japanese construction company is having a technical research institute. So I'm a member of the I'm a member of Technical Research Institute. So we want to expand our activity not only in Japan but also others. So especially now we are focusing on the Singapore. So my department in the so-called CATWIS, Kajima Technical Research Institute. So, the Singapore is a very, very crucial to not only gathering good information, but also disseminate the advanced technology. So, our role is to develop the new technologies, collaborate with the very, very good institute and the company all over the world. Okay, next, I'd like to explain our activity as a private construction company. Firstly, our Kajima Corporation declared the triple zero for until 2050. The triple zero means zero carbon, zero waste, and zero impact. I think it's so hard to achieve until 2050, but we must do it. For achieving this triple zero until 2050, we set milestones at 2030. So one of the milestones related to this today's workshop, the ZEB, Zero Energy Building, is mainstream. So our company targeting for produce zero energy building until 2030 as a major our construction product. So let me explain our policy for achieving zero energy building. So to achieve ZEB, we set 4 phases of the construction work. So firstly, you can see this one. First stage is eco-design. In terms of the front loading, it's a so big impact. So we mainly focus on this technology. The eco-design includes passive designing, but also introducing high advanced energy efficiency devices and facilities. The second is designing of the eco-conscious, the design leading to occupant for the eco-conscious. So, the big, it's not enough to introduce the facility and the building. To achieve the true ZEB, our human behavior is so important. So to nudge our activity to the zero energy, we are trying to establish the design way. The third way is a building operation phase. And so the building energy management is so important. So we also do in R&D to do more efficiently for the operating situation. Finally, this is this is an introduction of the renewable energy. Firstly, I'd like to show our example of these phases. Firstly, the eco-design stage. First of all activity for all the design, the facade design is so important. The facade is not only the heat source, but also the have a very impact of the well-being. So by introducing all the design method for the optimization of the facade, we can contribute the big impact of the energy savings. For example, you can see the two figures. The left-hand side is for the how to utilize the outside environment, not only for view environment, but also introducing of the lighting, daylighting. The right-hand figure shows how to mitigate the thermal impact, not only heating load, but also cooling load. So both combination is so important as a first stage. And we also have a lot of the design techniques. But as a second example, let me introduce the hybrid cooling system. Some people explained this system in this workshop. So these types of the system is very, very suitable for Southeast Asia region. This system is a combination of the ceiling fan, but also the conventional air conditioning system. This means this contributes at least 20 or 30% of the energy reduction, and furthermore, improving of thermal comfort. Many people want to get more wind. So by introducing this system, many occupants satisfy the thermal environment. Finally, this such kind of increasing the back air contributes a reduction of the COVID-19 infection. To be honest, I'm also a member of the supercomputer FUGA project, which contributes mitigation of the COVID-19 infection. By utilization of such kind of the supercomputing power, we understand this background air contributes to mitigation. So all of that's why we want to promote this technology. As a second topic, I'd like to explain the eco work style as a phase 2. So this is so important. Maybe you remember Professor Clayton Miller explained the importance of the nudging of the occupant behavior. So to do it, we need to establish the way. For example, if you open the window. No need to introduce the HVAC control energy. Fortunately, Singapore is a temperate climate, so a lot of availability for the outdoor area. So to nudge the occupant to such kind of eco-conscious activity, we are trying to establish such kind of the design. For example, to establish to introduce a large window. This leads to the people feel more comfortable, even in the high set point. The third point of the is energy management as a phase 3. But this phase is a very, very common for all people, especially in this workshop. So it's important to introduce the very, very efficient energy management for building operation. For example, the visualization and sophisticated management. But today I don't explain more about this. Yeah. Finally, we should use the renewable energy as a phase 4. So, so the one of the main resources of the renewable energy is solar PV. So this is very common, but we should consider next phase. For example, considering the integration with the building design, utilization of the building integrated PV system. So we are trying to establish such kind of the utilization, more sophisticated and wide use of the building. And second, so I think it's not suitable for this Singapore. This technology is mainly for the high latitude region. Our company established the multiple heat source networking. So by utilization of this, especially for the situation of the heating, we can reduce a large amount of the energy. For example, this case, one case, we can achieve 30% of the total energy for annual. Okay, finally, I'd like to introduce our new building in Singapore. This building is so-called the GEAR, Kajima Lab for Global Engineering, Architecture, and Real Estate. It will be open in June in this year. So this purpose of this building is mainly for the headquarters, but another purpose is for the R&D test bed. So to be honest, 6% of this building is mainly for the R&D. So we should, we will use a new technology for the energy saving. So this building has a 6-story, assumes maximum is 400 people in this building. So as a conclusion, you are interested in the energy saving in this building. So unfortunately, this is difficult to achieve the ZEB, but because we have a lot of the energy consuming facility as a R&D division. But we achieved the super low energy building on green mark. So there are a lot of reasons to achieve the super low energy. For example, one of the contribution is the radiation air cooling system. It's a rare case in Singapore. And of course, PV system also contributed. But this is a current calculation. We want to advance more. Firstly, we want to reduce more by 2 ways. One way is a very classical way. In this building, we have a semi-outdoor space as a workplace. You can see is a horizontal layout. For example, we also have a conventional air conditioning system, but at the center of this building has a large atrium space. This has a semi-outdoor. This means a non-air conditioning. But exactly speaking, this is a dual mode. If the outdoor condition is so hot or a very, very hazy situation, we can close. But most of all, we aims as a non-air conditioning situation. By the collaboration with NUS, we found that over 80% of the situation we can utilize as a workspace with non-air conditioning situation. So to reduce this energy consumption, we pursue the maximum utilization of this semi-outdoor space as an office area. Second is the utilization of the digital twin. Yeah, as a keyword of the digitalization, and this building is a full smart building. So this means that we can gather all information related to the building operation. Furthermore, we can collect and analyze. So based on this information, we can control more efficiently. So called machine learning based HVAC control. This R&D also contribute collaboration with NUS. At least we can expect 10 or 20% of the energy reduction. So the combination of new to classical and very digitalized way, we want to achieve more energy reduction. But currently, just it's an ongoing project. Later, maybe I can share the result at the next workshop. Yeah, that's all. Thank you very much.